In the notes 2C, I am going to be introducing 4 parent functions. Throughout the year, we're going to be talking about functions and their graphs and working towards just looking at an equation and knowing what the graph is going to look like without actually plotting a bunch of points. Our 4 parent functions, you're going to notice they're very simple. You can look across your page and see I've got the y is equal to x. Below this, you've got y equals x squared. Y equals the absolute value of x. On the next side, you've got y equals x squared and y equals x cubed. Parent functions are the simplest of certain function shapes that you can get. There's nothing multiplied, there's nothing added, it's as simple as you can get. So what we're going to do is we're going to grab each of these 4 functions and just note what their graph looks like. These are functions that you're going to need to know the tables and what they look like, really by memory. You should get that down. So we'll start off here, and I'm going to make a t-chart. I'm just going to use this. I'm going to make a t-chart on this, and I will let this be x. This will be my y. And when I fill this in, I'm always going to fill in my x's the same way. I'm going to put a 0 in, 1, 2, and then I'm going to do -1 and -2. Now this function where y is equal to x, that says that y is the same as x, so really we're just going to put over here, we'll come in and write this in, 0, y is the same as x, so x is 2, y is 2, x is -1, so y is 1, x is -2, so y is -2. I can write these as ordered pairs. This is 0, 0, 1, 1, 2, 2, -1, -1, and -2, -2. And I can plot these points, 0, 0, 1, 1, 2, 2, -1, -1, and -2, -2. And this graphs to be a straight line, which is no surprise. We already know how to graph y is equal to x, but it is introduced as our first and simplest parent function. So a line is a parent, and we already know how to move it around a little bit. The domain, we talked about domain last class. We're going to go from the low x value, which is the arrow. So we're going to go from -infinity is less than x, and to the rightmost x value, which is also an arrow, so it's less than infinity. The range, so the bottom here is an arrow, so it's going to go from -infinity is less than y, and the top up here is also an arrow, so it's less than infinity. So both all real numbers. So our first parent function. All right, so let's go down and look at something a little bit newer. Y equals to the absolute value of x. So again, we're going to graph this function on a t-chart. I'm going to have x. This time, y is going to be equal to the absolute value of x. I'm going to start with the same x values. So always get used to starting this way. 0, 1, 2, -1, -2. I'm going to plug 0 in, so the absolute value of 0 is 0. Plug a 1 in to my function. The absolute value of 1 is 1. Absolute value of 2 is 2. The absolute value of -1 is a positive 1. And the absolute value of -2 is 2. So plugging those x's in and simplifying, I get that. So again, these are ordered pairs, my x, y. So I have 0, 0 here, 1, 1, 2, 2. I have -1, positive 1, and -2, positive 2. So now take a look at that. It's going to form a V. You can just see it. It's like this is a line here. Going to continue out that way. And a line here that's going to continue out that way. So an absolute value forms a V at 0, 0. Domain. So from the leftmost x, so here's our left. It's an arrow, so we're going to have -infinity is less than x. And then the right here is going to be infinity because it's an arrow. For the range, the bottom, the low value, the bottom value there is at 0. And so it's actually got a dot on it, so less than or equal to y. And then the high value is here, and that is an arrow, so it's less than infinity. So that would simplify to be that y is on the big side of 0, so y is greater than or equal to 0, would be the simplified form of that. Function 3 we'll do is y equals x to the second power. Again, notice how simple it is, just very simple. So we're going to make a t-chart for that. So x, this time y is going to be equal to x squared. And I'm going to use the same x values. X is always the same. 0, 1, 2, negative 1, negative 2. I'm going to plug in to x squared, so 0 to the second power is 0. Put a 1 in for x, so 1 squared is 1. 2 squared is 4. A negative 1 squared is 1. And a negative 2 to the second power is positive 4. We're going to plot those values. So I've got the 0, 0, 1, 1, 2. This time it's going to be 1, 2, 3, 4. Negative 1, positive 1, and negative 2, 1, 2, 3, 4. This time, it's not, these are not straight lines. I can't draw a straight line between those 3 points. And so this is going to be a parabola. And it's going to curve up and hit those points here. So it looks along those lines. And they're gradually going out. They're going up and, to the right and to the left. So domain, my leftmost is an arrow here. So there's the left, there's the right. So I'm going to have that negative infinity is less than x is less than infinity. For the range, the low value right here. So 0 is less than or equal to y is less than, high value is an arrow, infinity. So again, this is going to be y is greater than or equal to 0, simplified. And this is called a parabola. Our last parent function, y equals x to the third power. Let's take a look at its ordered pairs that go along with it. So again, for the x, we're going to do 0, 1, 2, negative 1, negative 2. Our y is going to be equal to x to the third power. So 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. 2 times 2 is 4 times 2 is 8. Negative 1 times negative 1 is positive 1, and positive 1 times negative 1, negative 1. And negative 2 times negative 2 times negative 2 is negative 8. So we're going to graph those ordered pairs. And get 0, 0, 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, negative 1, negative 1, and negative 2, negative 8. So you kind of see the way they look. This is all going to curve together. So I will come down, go through these points. It kind of curves and flattens out at the origin, and then flattens out again and comes down this direction. So I get a look like this. It kind of does this little swerve move there in the middle. Domain. So the leftmost, this would be the leftmost here, actually. And that's left. And this is the rightmost here. Again, it's going to go from negative infinity is less than x is less than infinity. The range, this is the bottom, which is an arrow, and the top, which is an arrow. So it's going to go from negative infinity is less than y is less than infinity. All right, you are quite capable of putting together these parent functions and their graphs. You can do the ordered pairs easily. You can graph it easily. You just have to remember how to connect those dots, especially on this last one. But these are tables and function graphs that you need to be very familiar with as we move through the year. We actually will learn more parent functions throughout the year, and we end the year with that function project where we will again put everything we've learned together into making a design of some kind. So we'll continue this discussion next class. You don't need to do any more on these notes.